All right, so Metasploit CTF December 2020. Pretty easy, pretty interesting. So far we have gotten, I think, 8 of the challenges done. 2, 4, 6, 7 of the challenges done. 6 of which I was able to figure out. I think this 3 of spades is one I had not finished. I'm gonna do a quick walkthrough of the ones that I have done. A lot of fun, pretty interesting. I did learn some stuff. Um, some of the stuff wasn't really based on tooling, which I liked, but being able to do some stuff with tooling was cool. So to start off, thing that's different about this is just like the last Metasploit CTF that I participated in, they give you a Kali instance. It's your jump box, so you can operate from there, but that's just a pain in the butt because it's all CLI. And you can't do a lot of any of the tools that you have local, you can't really use without doing some type of proxy. So I'm going to show how I set up SSH to use SSH as a SOCKS proxy. So you can use proxy chains or Foxy proxy so you can connect to it. So to connect, you have your IP, username's Kali, and then you download your private key. There's only one target for this competition, so it's kind of nice. You're basically using everything against one host. So 172.15.5.5. Our Kali instance internal IP is 15.5.4, but most of the challenges are actually running inside of a container that doesn't have a connection back, so you don't have to worry about doing any type of reverse shell or anything like that. So to get started, I just ran I SSH'd into the box using the dynamic SOCKS proxy option. So I'm just going to try to find it up here. Here we go. So SSH / uppercase D for the dynamic proxy option. 8443 was the port that I used internally. Then I'm specifying my private key that I downloaded. Then Kali and the IP. And what that lets you do is on your local machine. Let me actually get this out. So if I do SSTLN, you'll see on my local host, I'm actually listening on 8443. So I'm actually able to direct any traffic that I want to 8443 and use that as a SOCKS proxy, and all the traffic will actually originate from our Kali instance that's running in the CTF. So that's what I've done. I went ahead, I configured Foxy proxy up here. Oops, sorry, clicked on the wrong one. That's burp. So proxy chains, localhost, SOCKS 5, and 8443. So when I toggle that on, it lets me, right now I actually have burp set up. So burp is actually acting as an intermediary between them. If you look here, I actually have it forward to a SOCKS proxy, which is the Kali host. So on 8443, that way I can actually intercept any traffic that I want going to the target and kind of look at some stuff there. So we're going to demonstrate a couple of the challenges and walk through those. So to start off with, obviously you do a nmap against the target. My history is a little ugly because I was messing with some stuff. So here's the nmap scan. So you'll see port 80 is open, which is actually the easiest challenge. You basically just go there and there's a flag. 1080, which I have not actually tackled yet. 1337 is a netcat challenge, some type of binary exploitation of some sort is all I can guess. I haven't had a chance to look at it. 445, I'm trying to remember which ones I've already done. Yeah, 445 I haven't done. 555, that's another binary challenge of some sort. 6868 is an information disclosure challenge. So we'll kind of hop into that. So you can see there's a lot of ports open. So there's basically one port for each challenge. So we'll just kind of start looking at each of the individual ones. So the first one, port 80, this is literally, you just, once you set up your SOX proxy and you point it to your browser to use that SOX proxy, you just load the web page and you get your first flag. So in order to actually get it, you have to submit an MD5 of the image. So you can literally just save image, or if you wanted, you could even do copy image location and then do like a wget, and that would let you download it. Obviously, if I was doing this on my local, I'd have to do proxy chains wget, which would grab that, and then you could do an MD5 sum of the, and there you go. You have your first flag. So that was the easiest one. The next one that I tackled was the password reminder. So on port 8123, salt-free hashes. So big hint, we're basically going to find a hash somewhere that does not have a salt that we need to break. So the first thing I noticed is there's a want to sign up and then a forgot password. And then there's also admin@example.com, admin login. I looked at the source. There wasn't really anything that stood out. Everything, there's no hints in the comments or anything like that. It's really just those locations. So we start gathering our information. We have a admin username. We need a password for them. So we go ahead and sign up. I think I did test@test.com. Notice the passwords can only be comprised of lowercase a through z and 0 through 9, which is terrible. So we'll just do something 1. Submit. Password is valid. We're not taking new members at the moment, but we'll get back to you. So nothing useful there. We can do an inspect element, see what we get here. Notice no cookies, nothing really in the way of the JavaScript. Really, it's just validating the password is okay. It's A through Z, 0 through 9, all lowercase. Also greater than or equal to 9 and less than equal to 14. So that's also useful. We can use that when we have to try to figure out the password. So the next thing we can go to is forgot your password. So we have that admin@example.com. So we're going to try that first. We do submit, and hey, guess what? The password begins with I hate salt. That's very interesting. We can also look in here and see what we get. So we get this post request with the password. Sorry. So here's our request. We're saying, hey, our email is admin@example.com. Our response that we get back is actually very, very broken. So we see that the password begins with I hate salt. So we know that we're going to be looking for a password, something related to that. And then we get the password hash for it. So to start out, we are just going to copy that down. So I went ahead and I saved that on my local system because Hashcat works much better. So I went ahead and I saved it here so you can see it's still in there. Save that. And so what I ended up doing was running Hashcat against it. So we can assume that rocky.txt is not going to be very handy because I hate salt is very specific. And that's also the beginning. So we need to brute force it, but we don't want to brute force the entire thing. So we're going to craft an attack against it. So we're attacking MD5 because it's 32 characters. My guess is MD5. It was right. The attack method is going to be 3. So that's brute force. I for incremental. Then we specify our hashes file. So that's it's actually in a directory up from my hashcat exe, so that's why I did the double or double dot. And then we create our own custom library that we're going to be using. So we're specifying library 1, and then we're specifying lowercase and decimal. So those are the options that we're going to have. And then we are doing a mask attack. So we are specifying I hate salt for the beginning. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So we already at the minimum. We know our maximum's 14. I think 1, 2, 3, 4, 5, 6, 7, 8. So I actually went over a little bit, but anyways, if we run this, it's gonna just, I already got it, but we'll see that I hate salt a lot 7. So we have the password. We can then go back, up a page, go to the admin login. I'm already authenticated, so there's our Black Joker. You can go ahead and download that, and you've gotten your second challenge done. The next one that I did was, I actually messed this one up for a bit because my Python was terrible. So 8080, it's a login page. You can see that guest is a valid username, but you can determine but can you determine what the other valid username is for the system? User observational skills. So if we do guest test, we'll see that it's taking a second. Yeah, so it's about 5 seconds delay for it to say, hey, it's a wrong password. So if we try something like blue test, kicks back immediately. So there's a timing issue going on. We're able to enumerate usernames based on that. There might be a tool. I actually thought about wfuzz after the fact. I actually just wrote a Python script. Let's look. Come on, I clicked over here. All right, where is... Yeah, so my user brute, pretty simple, using Python, import OS, import requests. I went ahead and started with the Unix users usernames. So opening that as read-only, setting my proxy because I need to be able to pass that to the end host. I could have done proxy chains. It's just easier to do requests through this. And this one I'm actually sending to burp just to check that I did it properly. And then so reading each line that's in there and basically taking each username in that file. So then I go ahead and do time because that's what I'm caring about. So request.post, specifying our host 8080 login PHP, so where we're going, using the proxies that I specified, and then the data that I'm passing is the username, and I'm stripping off the new line that was there. Then password test because it doesn't really matter what the password is, and then I'm doing a elapsed time total in seconds so that I can actually figure out what how long it took. And then I'm just checking saying, hey, if the time is greater than 2 seconds, go ahead and print that username. And if it's not guessed, I could actually remove this because that was just for sanity checks because I knew that guess should at least pop up and it wasn't. And that was my mistake for not removing the new line. So we can go ahead and run that. It actually runs pretty quick when it's working properly. So Python 3, user brute. It'll take a little bit and it's going to kick back the user demo. So if we go back here, yep, demo. So it took 5 seconds, which is about in line with what we saw for guest. So we can put in demo, congrats. Now you can visit this page. So it's a random page, could have brute forced it, but it would have taken a while. And you get your next flag. All right. The next one that I did was actually 9070 or 9007, and it literally is just a zip file titled Red Joker. And so I took a look at Red Joker. I started out doing a file against it. It says it's a zip file, but if you try to unzip Red Joker, it gives you some issues. And I just kind of was like, okay, well, what if I just use binwalk? And so I checked with binwalk. Oh, there's an extra W in there. You can see that there is a bunch of stuff in there, including a PNG Red Joker. So I went ahead and just used the TAC-E. And it went ahead and actually extracted it. So we can just CD into the Red Joker folder. And there we go. Red Joker PNG. And if we actually look at it, that is what it is. It's not some joke. So you can MD5 that and you have your checksum on that. All right. Next one was 6868, which was an IDOR. So we get here, looking at it, it's like, all right, we have some names of people. So Barry D. Villanueva, Tanya Wallace, Malcolm Cooper, sign up. So sure, why not? So we're going to use Shift D. And it's actually important to use a middle name here that I did not know. So we'll use sometimes and then sheep. So then we'll submit. Only uppercase. I forgot about that. So it's all uppercase. And so we get a view at our notes. Well, notes available aren't for new users. Okay, well, that's kind of annoying. But we'll notice that SSS is now our directory. Well, we can go back to the front page. Here, let's open this in a new tab. And if we take a look at some of the people that are here, so we have Malcolm Cooper. Okay, well, if they have no middle name, can we see anything from Malcolm Cooper? Oh, we can. Sweet. So IDOR. We're not supposed to be able to see this, but we can. So we can kind of go through and see everything, and it's really kind of strewn throughout all of them. So we get a middle name of somebody, UDD, some lady that works there. So we can look at the next one. So Malcolm, Tanya. And it's not 2, I think it's 1 or 0 somewhere in here. There we go. So respond to Miss Yeager's to confirm okay with the site changes. So we now have UDDY. And if we go to Bill D. Bagel is okay today, not what we care about. Beth. So Buddy. Well, that's funny. All right, so Buddy 0. Hey, 6 of hearts. So we need to find it. The other thing you can notice is if we look at these image locations, files, whatever their username is, and then a number. So we can switch it from notes to files. Computer helped us, not what we care about. What we care about. Hey, there we go. And we got our next flag. Then the last one that I was able to get was 8200, which was a file upload bypass. So we have a gallery. We're able to view some images. That's the 4 of hearts, which we already had. I'm assuming somebody on my team uploaded that. I don't know if they left that there as a joke. But you can see like 4 of hearts, untitled, download. So it looks like some people were uploading some random things. And then that's my shellcode that I uploaded. So if we come over here, we can see that we have the ability to upload without any type of authentication. I tried a couple of things. You're not able to upload anything other than a PNG or a JPEG, I believe is what it wanted. So I'm not sure how the PNG got there. But anyways, what I ended up having to do is craft a file that had a PHP payload that allowed me to still upload it. So I had to actually include a JPEG magic byte at the beginning and utilize a JPEG file type in the file name. So what I ended up doing is, where is it? Shell PHP didn't work, so test JPEG PHP is what I ended up with. So if you look at the file, sorry. Oh. Oh. This is what it looks like. It's ugly because the magic byte does not process well in Nano. But what I ended up doing is I just had a JPEG. I removed everything but the first line and then trimmed it down so it was just the specific hex that we needed, so that it would match the magic byte. So if you don't know what the magic byte for a JPEG is, so I ended up with, I think it was this one, the FFD8. Or actually, no, sorry, FFD8, I think is what it is. So you can see it if we go to hex edit and look at the actual file. So FFD8, FFE1, yeah, so we use this one. And it looks like these 2 bytes don't matter. So you can ignore those, but then you got 4578, 6966, 0000. And then I zeroed out everything else leading up to here. The 0A is a new line. And then my payload is there. So all we're doing is checking if the command parameter is set. And if it is, then we go ahead and we get the command parameter. And then that lets us execute commands. So if we go to upload this, so first I will show you one of the, so I tried a GIF. So simple PHP GIF, upload, unsupported file format. So it didn't like GIF. I tried changing it to, we can rename that one quickly. Simple PHP GIF to simple JPEG.php. And we'll see that unsupported MIME type. So it actually is checking that magic byte. You can't just upload whatever you want. So now that we have our crafted JPEG, go ahead and upload the image. It uploads successfully, and we can come over here and we have our image, which all it says is exif, so it looks like it's broken. But what you can do is cmd ls, and we have command execution. And so we can go up one level. Oh, sorry. We have to URL encode our think it's 2F. Oh, sorry, I'm retarded. It's, there we go. And it's actually kind of easier to do it this way. If you page source, so we can see that there's this random, I'm assuming, directory here. So we're going to copy that. What was the end of it? 2. Yeah, I don't think I copied that right. Let's try that again. There we go. So 6 of diamonds. So then we can just do a request. So we'll see that we're actually specifying this images folder. So we could just do 6 of diamonds, and we have our flag. So I think that does it for all of the flags I was able to get. We had the IDOR, we had the stego, file upload, the password reminder that didn't have the salt, the timing based enumeration, and then port 80. And then I was working on port 9009, which is actually an SSH. So if we do proxy chains, SSH 9009 admin, I had to run Hydra, but the password was password, so not very difficult. The next part is trying to figure out where to go from there. So I was at least able to figure out that there is a SUID binary here. I haven't been able to figure out how to elevate permissions yet. But there is this specially crafted VPN connect. I was able to figure out that the username and password from it by reversing it is username and secure pass. I always try to type admin. P secure pass, and then you need to specify TACL because it's not actually optional, because the destination where it wants to write is not available. So I just did temp test2, and so it says you're authenticated, but I haven't been able to break it. I know that there is a shared library that is in the user lib section, lib vpn auth custom.so. I'm able to read it, can't modify it. Owned by root, so it's very similar to the opt VPN connect. So I'm going to be interested in seeing how that turns out. But yeah, that's the challenges so far. Pretty easy, pretty interesting. Look forward to the next one. Catch you guys later.